Please be seated. So welcome, ladies and gentlemen. Welcome to the Eindhoven University of Technology. And thanks for coming to Alexander Serebrenik inaugural address. Let me start with a very short story. Not long ago, I read a story about a big tech company introducing new software. It was at the end of the 90s. The company performed focus group testing for the new software. The results were kind of negative. Most of the women in the focus group thought the characters were too male and that they were leering at them. One of the women was going through the results afterwards. She was in a room with the software development team, around 12 guys. They just didn't get what the problem was for women. She replied, guys, look, I'm a woman and I'm going to tell you these animated characters are male looking. The software failed, of course. This is an example from about, nice. Okay, no, we'll not touch it anymore. This is an example from about 25 years ago, but the subject is more relevant than ever. This is why I'm very happy that Alexander has made this his research topic, focusing on software engineering as society. His research goal is to facilitate evolution of software by taking into account social aspects of software development. In an interview with Alexander, he said, I have changed my research topics several times, mostly due to the realization that a more profound understanding of a problem required complementary perspective. That is why he involves theories and methods from both within computer science, like machine learning, methods from natural language processing, and from outside computer science, like organizational psychology. Alexander started at the Hebrew University in Jerusalem, where he received his bachelor's and master's degrees. After that, he went to the Katholieke Universiteit Leuven in Belgium, École Polytechnique in France, and in 2005, he joined our university as an assistant professor. In 2013, Alexander became an associate professor, and now, I proudly say, he is our new full professor of social software engineering. His research work is impressive. Alexander has co-authored a book, Evolving Software Systems, and more than 220 scientific papers and articles. He's actively involved in organization of scientific conferences and is member of several editorial boards. Not to forget, he has won multiple best papers and distinguished review awards. Alexander focuses on software development, one could say. I would say he focuses on human beings and on respecting and acknowledging every single one of them. Dear Alexander, I was just talking about your scientific work. I am very impressed by this, and I'm honest at this one. But I am equally impressed with your commitment to the LGBTQI community. Not only are you a member of the 2022 Diversity and Inclusion Committee of the IEEE Computer Society, the largest global community of computer scientists and engineers, but you are also open to colleagues who need advice or just someone who listens to them. Thank you. It shows that as a person and as a human, you are able to look beyond science, and that is something very special. I wish you every success as a professor at our university. Thank you, and I would like to invite you.
Thank you, meneer director. Thank you, Edwin. And I would like to thank all of you for being here, for coming to this strange, tense, and celebratory moment. And of course, thank you very, very much for supporting me through all those years, because without you, without your continuous support, I would never been able to stand here and talk to you about the topic which makes me passionate. So let us talk about software. Software is, of course, being developed for people and by people. And it is this by people part that we are going to focus on today. And of course, software, as almost any complex system, can never be developed alone. And if you look around, you'll find lots and lots of expressions that are hailing benefits of collaboration. Think about, two heads are better than one, teamwork makes dream work, and so on and so forth. But of course, both in our personal and our professional lives, we know that not every group of people is actually capable of successfully working together. And necessarily difference in opinions can lead to all kinds of conflicts, ranging from mild disagreements to completely destructive situations, which would make any kind of collaboration impossible. So those observations are, of course, not new. They're not new in general, they're not new in software engineering. So in fact, already in the 60s, when Fred Brooks was observing a project called OS 360, he saw that adding developers to a project which is already delayed delays it only further. Essentially because you cannot solve this communication problem by merely adding people. This has been summarized by his book, The Mythical Man Months, which was published in 1975 and is often mentioned as one of the most important software engineering books ever published. So moving from 75, the year I've been born, to 2022, the year we are now. And of course, lots of things have changed since 75, right? Software has changed. Today, software is everywhere. And in the same way as oxygen is an invisible element, invisible gas, which makes almost every life form possible, software is often an invisible element which makes essentially anything possible, ranging from interpersonal communication to companies, to businesses, to social lives, and so on and so forth. In fact, every company nowadays can be seen as a software company. But of course, not only software has changed, but also the way it is being developed has changed. So already in 75, Fred Brooks was talking about developers depending on their colleagues with whom they're building things together. Today, developers depend on components and subsequently their peers who might be across oceans, across time zones. They might be paid, they might be volunteers, they might be coming from all possible walks of life. And it is very, very different than what has been done in 75. And of course, nowadays, the society has changed. Today is much more attention being paid to things like social safety, to things like diversity, to things like inclusion. The society of 75 and the society of 22 are very, very different. And this essentially calls for a renewed attention for the society of software developers, because we need to understand how developers work and who they are and how they feel. And personally, I believe that creating a better society of software developers allows us to create a better society for everyone. So what does better mean? There can, of course, be many definitions of what a better software means, or better software society means, but for me, it's all about inclusion. It's all about bringing yourself, your full self to your work, recognizing that your contribution is being appreciated by the organization or by the project you are working on. From the management literature, we know that when we talk about inclusion, we actually talk about satisfying two complementary needs. One is related to uniqueness, another one is related to the sense of belonging. So if we sacrifice one of the two in favor of the other, we are not really talking about inclusion. So when we have studied public discourse surrounding age and ageism in software development, we have seen that older software developers, and older in this context typically means 40 plus, so I'm already old, would typically they would be required to sacrifice some of their uniqueness, to blend in, for example, adopt useful patterns of behavior, to work extra hours during the evenings, weekends, and whatnot, to lie on their CV. Some software developers go that far that they take performance-enhancing medication or perform plastic surgery to blend in with predominantly younger crowd. And at the same time, of course, we know that in some companies, older software developers are singled out. So when somebody is singled out, their uniqueness is recognized, but the sense of belonging is nowhere. So this means that as a social software engineering student, the primary duty we have is to understand the experiences of software developers from minoritized groups, such as older software developers, such as LGBTIQ software developers, such as women who are developing software, and so on and so forth. So what I'm going to do next, I'm going to touch on three things. I'm going to briefly discuss what we know about experiences of minoritized software developers. I will say a couple of words about what do I think we need to learn, we need to understand in the coming years. And finally, how we can convert this kind of understanding to actual support of developers from the minoritized groups. So when we look into the literature, lion's share of any kind of studies of diversity in software engineering is focused on gender, and specifically it focused on gender in its most binary interpretation, comparing experiences of women with experiences of men. So we know, for example, that when joining open source projects on GitHub, women tend to disengage faster. So after 12 months, roughly 70% of men are still contributing to such a project, while for women this percentage would be around 60%. We also know that women tend to focus their effort on smaller number of projects or smaller number of organizations than their peers who are men. At the same time, there are no differences between, for instance, engagement of women and men on mailing lists of such projects as Drupal and WordPress, or in their productivity. Yes, there are differences between different projects, but in general, there are no differences in productivity, at least when it's measured as the amount of code produced per time unit. Much less attention has been spent on other diversity axes. For example, we do know that contributions of GitHub developers coming from countries with low human development index are more likely to be rejected than those of developers coming from countries with high development index. Ayushi Rastogi, who is here, has observed that contributions of developers from Switzerland are twice more likely to be accepted than of their peers from China, for example. The study with Sebastian Baldes and George Park on older software developers has clearly shown that older software developers are often stereotyped as rigid, as not being able to master new technologies, and their experiences are branded as technological baggage that essentially you need to throw away because it's no longer relevant. And of course, there are some studies, such as this one by Ringel Morris and their co-authors, about neurodiverse developers. So neurodiverse developers experience more challenges when it comes to working in public spaces, in open spaces, and so on, than their neurotypical peers, and also have more challenges communicating with those peers. So how do we proceed? Where do we go on from this? Even when it comes to gender, which is the most studied diversity axis in this kind of space, we need to be more careful when studying it. There are almost no studies of non-binary genders in software engineering. There are actually very few studies of non-binary genders in general in collaborative work and none in software engineering. So together with Diné Ford and Reed Milevich, we have done a very first step in this direction by conducting several interviews of transgender women who develop software. And we have observed that many benefits they can reap from this kind of activities are related to remote work. They can learn new skills by watching educational videos. They can work on bounty platforms, essentially disconnecting their skill and their identity. And of course, it's much easier to disengage to leave a company or to leave a project by closing your laptop than actually by stepping away from the company. However, this is only a first step. We do not know to what extent this kind of experiences and this kind of benefits are shared by other groups of developers. When it comes to nationality and geography, if you look at this map of Evans Digital Corporation, we see that South America and Asia are the regions where the growth of the number of software developers is going to be the highest in the coming years. So the other map shows, however, that those are regions where the mastery of the English language is not as high as, say, in Western Europe. So what does it mean for us? This means that whenever we are conducting studies of software developers, whether there's interviews or surveys, we need to communicate in other languages. Maybe we need to run a survey in Chinese, in Japanese, in Portuguese, or in Spanish, rather than only doing it in English as customary today. And of course, focus on English-speaking developers is not the only blind spot we have. So I've been talking about software developers, but not all people who are actually developing software consider themselves software developers. For instance, they might be researchers, they might be computational scientists who are developing software merely as part of their research. They don't necessarily care for the software, but rather they care for the results which can be obtained using it. And on top of it, we tend to use software developer and software engineer interchangeably. But this is, of course, not exactly the case. Even in the Netherlands, we have two different titles of engineers, ING and IR, depending on what kind of university you went to. And in one of the recent interviews I have conducted, a person who was trained through a boot camp reported that they are continuously being put down by their more classically trained peers, stating that, this kind of boot camp training does not make them to a real developer or to a real engineer. So all those things, all those attributes, all those aspects are, of course, not working in isolation. As we know from the work of Kimberly Crenshaw, individuals which are located on the intersection of multiple diversity axes experience additional challenges which cannot be reduced to challenges related to each one of those axes. For example, one of my master's students who recently graduated, Sterre van Breukelen, she has interviewed a series of older women who are developing software, and many of those experiences could not be attributed specifically to age or specifically to gender, but rather to the interplay between the two. Another example in this field is a study of black women who are much less likely to be introduced to computing through their friends or family than non-black women or black men, right? So we have a situation when essentially those multiple diversity axes or multiple discrimination or disadvantagement axes are reinforcing each other. And this is also what has been studied by Elin Čech, who has compared multiple intersectional groups with the nominal group of heterosexual white men without disabilities, or those of you who are living in the Netherlands and familiar with some of the Dutch discourse might recognize as the Zeven Winkjes, which is essentially the counterpart of this group. And so this image is related specifically to the sense of belonging, but there are similar plots for income, for turnover, for promotion chances, and so on and so forth. They all show that the more intersections you are at, the less likely you are to feel belonging, to earn money, and so on and so forth. So this calls, of course, for more attention for this kind of experiences, for experiences of developers who, for whatever reasons, are at intersection of different axes and interplay of different mechanisms. So when it comes to supporting developers, I like to think about this kind of ladders. So what can we do to help a person to climb a ladder? We can try to give them a better tool, for instance, a better rope they can hold on to when climbing, Or we can also teach them a better climbing mechanism. Firefighters are, for example, quite often specially trained on how to climb a ladder in a safe way. So when it comes to our tools, I would like to mention the GenderMag project, which has been initiated by Margaret Burnett in Oregon State. So the basic idea of GenderMag is focusing on 5 cognitive aspects that show differences, gender-related differences. For example, if you ask people whether they are motivating to explore new technology, then typically more than 2/3 of men will say yes, while for women this percentage is around slightly less than 40%. On the other hand, if you have an answer no, then more than 40% of women will say no, and only 10% of men. So it's not the only variable which shows this kind of gender-related differences. Think about risk-averse versus risk-taking. Think about information processing, which is either comprehensive or heuristic, and so on and so forth. So while each one of us can be somewhere on the scale between yes and no, there are groups, for example, I am a risk-averse person, but my information processing style is heuristic, meaning that I'm choosing the risk strategy which is more common among women, but I'm taking information processing strategy which is more common among men. So there are still clusters of those elements. This means that we can try to position ourselves in the shoes of a person who is embodying those cognitive strategies which are more common among certain genders. And that's exactly the idea of GenderMag. So Burnett and Sarma have proposed personas known as Abby and Team. Abby is an implementation of cognitive strategies used by women. So she is not motivated by technology, she is risk-averse, she uses comprehensive information processing, and so on and so forth. And then the task of developers during the GenderMag session is to put themselves in the shoes of Abby and try to think about whether she will be able to formulate the next goal she needs to reach, and whether she actually will be able to reach this goal, given who she is. But of course, gender is only one dimension. And in the same way as we have GenderMag today for gender-related differences, we need similar approaches for all other kinds of differences, which might be related to age, which might be related to background. For example, if we are talking about age, then one of those cognitive aspects might be memory, because we know that memory becomes less and less powerful as people age. So we need more of this kind of tools, more of this kind of approaches. When it comes to techniques, when it comes to helping people to climb the ladder, then of course we can think about mentoring. And this picture has been taken during a mentoring lunch at the International Conference on Software Maintenance I had the privilege of hosting here in 2013. And some of you might even recognize people in the sitting at this table. And Janja Daisuren, who is also there, she is actually also there, but I'm afraid we don't really see her. So when it comes to mentoring, mentoring really helps developers from minoritized groups. But their expectations can be very different. For example, LGBTIQ software developers usually appreciate being mentored by more senior LGBTIQ software developers. However, those of them who are not out might prefer not to be mentored by an LGBTIQ mentor out of fear of being seen as LGBTIQ by association. So this picture is actually taken by members of Compass, and I'm very happy to see board members of Compass sitting in the audience. Thank you for coming. So to summarize this part of the talk, when it comes to experiences of software developers from minoritized groups, most of the literature has focused on differences between women and men, focusing on gender in its most binary interpretation. As the next steps, we definitely need to go beyond this interpretation and beyond gender. So we need to look at experiences of people who are not formally trained as software developers, who do not necessarily see themselves as software developers, who are not speaking English, and so on and so forth. And of course, we need to look not merely at the individual aspects, but also at the interplay between those aspects, as the intersectional perspective actually calls us to do. And of course, we need to convert the insights obtained in this way to tools and techniques, to ways of climbing this wonderful ladder to making people feel more included and at the same time their uniqueness being recognized. However, as I already said, software development is rarely an individual activity. There are typically teams that involved in creating software systems. And this means that this entire discussion of minoritized developers has also been lifted to the level of groups, to the level of teams. And this is where we are talking about diversity in groups and inclusion in groups. And I'm going to touch, albeit briefly, on 4 things. The first topic will be related to diversity itself. How is a team composed? What do we know about more diverse teams as opposed to less diverse teams in terms of their software engineering output? The second picture corresponds to communication within the team. Here we see that, for instance, the yellow person with curly hair is receiving lots of incoming messages. Maybe it's a manager, maybe they are just liking to talk, but at the same time, a person who is located next to them seem to be excluded. They do not receive any kind of incoming messages. So what does it actually mean? And of course, nowadays, and this is again 2022, communication between developers often involves some kind of automation mechanisms, whether they are bots or other automation mechanisms such as continuous integration and so on and so forth. This kind of mechanisms influence how developers work and talk together. They see different things through the lens of those bots. And the last element will be related to the context we are working in. Those teams influence, the team composition influences project composition at the level of source code, for example, and at the same time, specifics of the project influence how people see each other, and in particular, how people see developers from the minoritized groups. So when it comes to diversity, one of the very first papers we have published on this topic, it was 2015, so we have seen that gender diversity is beneficial for productivity, meaning that more gender diverse teams are more productive than less gender diverse teams. And we have also seen that more gender diverse teams are not necessarily leading to people deciding to leave the team during the next period, as opposed to, for instance, teams which are diverse in terms of experience, here called tenure diversity. Another study was conducted by Daniel Agarwal and Stewart, and they have looked, for instance, at national diversity. And they saw that the cultural diversity is beneficial for community engagement, but not necessarily for market success. So depending on what you want, you might or might not be interested in this. However, those variables are not really independent. And I'm just going to mention 2 examples, one from the Netherlands and one from India. So if you are looking at software development companies here in the Netherlands, and particularly if you are looking at women who are working at software development roles, many of them are not Dutch. And it's not surprising. It's not surprising given the low number of women choosing to study computer science at any kind of Dutch university or University of Applied Sciences. So subsequently, companies hire people from abroad, and among those, among women, there are more of people coming from abroad than among men, percentage-wise. So this means that gender diversity in a team, at least in a Dutch context, will be interplaying with national diversity. So we cannot really tease those 2 separately. Another example is coming from India. To the best of my knowledge, in India, women are actually encouraged to study computing. This is why you will see relatively many women entering computing. However, at a certain age, when they would like to establish families and marry, they are being encouraged to leave professions and essentially focus on household and their private lives. So this means that, again, if we are looking at a team which has many women, those women are more likely to be of a certain age. This means that gender diversity is intersecting here with age diversity. So as a first step in this direction, trying to combine multiple diversity axes in teamwork, together with Stefano Lambiase and other folks, we have tried to understand how diversity influences communication in software teams. So on the left, you see different diversity types, gender diversity, geographic diversity, and so on. In the middle, you see suboptimal communication patterns. So there are many of those suboptimal communication patterns. Here there are only 4, and I'm only going to focus on one, on the black cloud. So black cloud is a suboptimal communication pattern which corresponds to the situation when there is so much communication going on that people can no longer distinguish useful communication from useless communication. And those fat lines on the schema show that gender diversity index is negatively related to black cloud. So more gender diverse teams are less likely to exhibit this kind of black cloud problems. And this is related to the fact that women tend to take mediating roles in teams, structuring the communication. The moment the communication is better structured, it is less likely that you are lost at discussions. When it comes to geographic diversity, it's also negatively related to black cloud, but it's not so much that, merely being across oceans somehow helps you to organize your communication. What happens is that because you are so far from each other, you cannot just go to your neighbor and tell hi and discuss whatever you want. This means that you are going to use some kind of tools. And if you are talking about tools such as Trello, such as Slack, such as Discord, such as Gitter, all of them have some form of clustering spaces. Those can be channels, those can be rooms, whatever you can like to call them. But this mechanism allows people to know what they're essentially talking about in this particular subspace. And this is exactly what organizes communication, and this is exactly what helps people to distinguish useful and useless communication for them. Of course, this kind of discussion of community smells of those suboptimal communication patterns is predominantly related to who is talking to whom, and not necessarily about how they are doing it, what they are talking about, or what kind of emotion is involved in their communication. And this topic of sentiment and emotion in software engineering is an active research topic. Recently, together with Bin Lin and Nathan Cassé, Nicole Noviele, Gabriele Bavote, and Michele Lanza, we have focused on a study which surveyed more than 150 papers. And this is a reason why I'm mentioning all the authors here, because without all of them, this work would not have been possible. And on this slide, we see a list of tools which have been used or mentioned in the papers we have surveyed. So the tools with an asterisk to their name are commercial tools, and the tools in the bold phase are tools which are not only introduced or evaluated, but are actually used to infer any kind of insights in software engineering processes. So what do we see? First of all, we see that quite a number of those general-purpose software and sentiment analysis tools are used to infer insights in software engineering. And this is profoundly problematic because we know that those tools are not reliable. Their results, the tools produce results which are inconsistent with each other. They are inconsistent with how humans perceive sentiment, so essentially don't use. A counterpart of this is that, of course, that there are many sentiment analysis tools which have been designed specifically for the software engineering domain, but they're actually not used. So all those tools not in boldface are actually not used. And the last observation, which is due to Nicole Novielli and her co-authors, is that there is no such thing as a software engineering text. There are many kinds of software engineering texts. And when you are reporting a bug, you are talking, you are writing in a very different way compared to when you are asking a question at Stack Overflow. So this means that there is no silver bullet, right? So those tools have to be adjusted, have to be trained whenever we are applying them to a new context. Unfortunately, this rarely happens in actual studies. Negativity in communication between developers can be related to toxicity. It's not always the case, but often it is. So toxic communication is rude, disrespectful, or unreasonable language that is likely to make someone to leave discussion. By definition, toxic communication is a form of exclusionary behavior. And of course, toxic behavior has been observed in numerous open source projects, as well as in such platforms as GitHub and Stack Overflow. Developers are aware of toxicity and toxicity problems, and looking on GitHub, one can find several attempts to address this problem, several bots which have been designed to detect toxicity in developer communication. However, acceptance of this kind of bots by developers is really a big, big problem. Because, of course, why should I, as a human being, allow some kind of stupid machine tell me how I'm supposed to behave? So this kind of policing by bots is by far not trivial. Moreover, the entire concept of toxicity is being called in question. For example, some people would argue that the use of profanities in communication is an example or is a feature of toxic communication. However, Linus Torvalds has repeatedly argued that use of profanities is his typical Finnish management style. Well, Linus Torvalds might, of course, be an oddball. We all know it. But there are also studies which essentially show that the use of profanities can contribute to increased cohesion within the team. So while, yes, it can use an exclusionary mechanism towards the outsiders, it can actually work as a cohesion strengthening mechanism for people who are inside the team. And of course, toxic communication can lead to conflicts. And again, conflicts can come in all kinds of forms and shapes, ranging from minor disagreement to profound conflicts. And I'm very, very happy that Samar Jamel, a master's student present here, is going to look at this topic together with Nathan Kassé and myself, of course. So I'm having extremely high expectations. No pressure. So, of course, when it comes to this kind of conflict, to this kind of disagreements, we can focus on detecting them, but detecting them might be too late because, of course, you know, once the problem is already there, it's relatively apparent to every party involved. So what becomes interesting is to understand what kind of scenarios can lead, what kind of scenarios can trigger this kind of conflicts, and which is more interesting, how to solve them. So here we see Olive and Mabel. Those are not my dogs, but of course I could not give a talk without dogs. So here Olive and Mabel are interested in the same artifacts, in the same toy. And this is the reason why there is a conflict here. So one possible conflict resolution strategy would be to remove a toy, to remove essentially what triggers the conflict. But it's, of course, not always possible. So good news is essentially that conflict resolution strategies can be trained. In particular, they can be trained by people who are cognitively flexible. And this is also a topic I would like to explore together with Sonia Rispens, who is Associate Professor at Industrial Engineering. At the same time, toxic behavior, conflicts, and so on have, of course, been observed by developers themselves. And one of the mechanisms which has been proposed both by companies and by open source projects is an introduction of code of conduct. So today, almost every company has a code of conduct. Our university is not an exception. We also have a code of conduct. Already in 2016, more than 10,000 GitHub projects have adopted Contributor Covenant, which was the most popular code of conduct, and so on and so forth. But of course, codes of conduct, okay, what happens here? Okay, so but of course, codes of conduct are not a silver bullet. Controversial decision by a project maintainer can, for example, lead to so-called normative conflict. So essentially to a situation when instead of discussing how to behave in a specific situation, the community moves to questioning, do we really believe in this? Is this really the code of conduct we want to adopt? On top of this, specifically on GitHub, code of conduct is being threatened by two complementary moves. On the one hand, there are several mocking attempts. Here we see a no code of conduct. There is also something which is called code of coffee. All those things essentially are mocking the idea that we need to decide and we need to agree how we communicate and how we work together. The basic idea here is that we are all adults, shit happens, deal with it. This is, of course, a problematic attitude because people might prefer simply not to participate in this kind of communities, leaving this kind of communities without their knowledge or their skill. On the other hand, GitHub, probably motivated with the very best goals, has made it extremely simple to adopt a code of conduct. Adopt code of conduct in this case means to add a file called code_of_conduct.md to the repository. You just click on a couple of buttons, you enter your email address, and you are done. But of course, this doesn't really mean anything about the change of the community norms that this code of conduct is pertaining to. And in fact, it becomes extremely easy to signal virtue and attract people, actually putting them at risk because the community didn't really change. So you are going to harm people whom you are supposedly protecting. As I already mentioned, communication nowadays often involves bots. So we have already seen bots which are trying to detect toxicity, but of course, in practice, they are doing much more. They're evaluating quality of the source code. They are reminding developers to perform certain actions, such as signing a license agreement, and so on and so forth. So those bots influence how developers communicate, how developers work, because in fact, they are moving from merely tools which are being used to fully blown partners with whom developers are communicated more or less in an egalitarian way. This, of course, calls again for this question, what kind of behavior is acceptable for developers, what kind of behavior is not, and whether we see differences between developers, projects, and bots. Just to show you a couple of early examples we have obtained. So this, the first table is coming from a work of Marielle Wessel and a group of Brazilian researchers. So you see here that involvement of bots makes developers more productive. They are implementing more changes, they are merging more pull requests. Their quality tends to go up because fewer pull requests, fewer proposed changes are being rejected. And what's more important, they communicate less. Essentially, there is no need to talk about things that the bot has already taken care of. And this observation is close to the observations that Nathan Casser has made during his master thesis, when a similar phenomenon has been observed for other form of automation, specifically for continuous integration. And while the picture might not necessarily convey this message, in general, one could argue that roughly 1/3 of communication is decreased when a continuous integration solution is implemented in an open source project. The last element I want to mention here is this interplay between composition of a team and the context it's operating in. We already seen this schema in the upper part of the slide, but now I want to focus on the rightmost column. So just to remind you, leftmost is diversity variables. In the middle, we have those suboptimal communication patterns, but the rightmost is related to suboptimal organization of the source code itself. So-called code smells. And of course, there is an interplay between those variables. So for example, if I'm developing my code somewhere independently from the entire team, I'm not looking at my peers and I don't care what my peers are actually thinking, then I'm not going to put myself in somebody else's shoes and I'm not going to think how they would look at my source code. This means that I'm not going to structure this, and this is exactly a feature of spaghetti code. So if I'm a lone wolf, then it is likely that my code will look like spaghetti. And connecting those elements, we can say that diversity variables influence communication, and communication in its turn influences artifacts, such as source code. Moving to the other direction, so namely what make project-specific elements which are influencing diversity variables, we can look at, for example, at NASA. So I already mentioned that older software developers are typically stereotyped as rigid, their knowledge as irrelevant, and so on and so forth. But for NASA, this is absolutely not the case. At NASA, the reliability expectations and requirements are so high that they make more junior developers appreciate experiences and war stories of their more senior peers and older peers. This is in a sharp contrast with what we see in software development in general. So yes, we need to distinguish between different contexts if we want to understand collaboration and communication. And again, moving from insights to support, how can we help people? In this case, how can we help teams to climb our ladder? So in this case, I would like to mention 2 projects I am going to start working on in the coming months. One of them is collaboration with Professor Anita Sarma from Oregon State. We are going to help developers from the Apache Software Foundation to get insights in their teamwork through the diversity lens. This involves creating a dashboard that would help them to see how they are doing with respect to certain communication expectations and certain diversity expectations. On the right hand, we see here a colleague, Professor Martin Hornings from the Built Environment faculty here in Eindhoven. So we are going to work together on acoustic software, which of course I don't know anything about. That's Martin's expertise. But I will be more than happy to support this effort by creating an open source community of developers which can make this open source software, open source acoustic software, to a sustainable solution rather than yet another academic project which is evaporating as soon as the funding is finished. Of course, studying social software phenomena, so the social software engineering research, is not without its obstacles, it's not without its challenges. And mostly they are related to 4 elements: data, theories, context, and education. So you might have noticed that lion's share of the work I've been talking about is essentially based on some form of data. We like our data, it's our precious. And of course, we like our data, more data, we want to have better data, more diverse data. But ultimately, all this data is about human beings, meaning that we are, of course, subject to legal and ethical expectations and regulations, such as the GDPR. And our ethical review board in Eindhoven are my very best friends. I think that I'm ensuring that they are not staying without a job for the coming years. And of course, theories, right? Edwin already mentioned in the introduction that in our work we tend to use theories both from computer science and from outside of computer science. And this is partially because software engineering is not necessarily known for having many extensive universal theories. There are a couple, but not that many. So we are trying to borrow those theories from such fields as organizational psychology, but of course we don't know whether theories actually work. So whenever we are borrowing something, we need to evaluate, does it work, doesn't it work, and what are the limitations of those theories. And of course the context. So the context has been called a king on so many occasions, and there's also the reason why those universal theories rarely work for us. Things which work in a small village do not work in a megapolis. Things which work in a small project do not work in a large one. An app is completely different kind of software as opposed to the NASA software, and it influences how people are interacting, how people see themselves, and how people see their peers in those contexts. And finally, education. And education is, of course, it's not only one of the two primary tasks of ours as university professors, but it's also related to the fact that we are continuously working with student teams. Student teams are sometimes composed by teachers, sometimes created by students themselves, but diversity and inclusion are rarely taken into account when the teams are composed. In a recent study we have conducting across several universities of technology in the Netherlands, we have observed that lots and lots of students have never had experience of working, for example, in a gender diverse team. Unfortunately, we know that lack of experience also tends to mean lack of appreciation. People who didn't have this experience firsthand don't necessarily understand why do we talk about importance of diversity. So we do need to do something about it. And of course, in general, in the same way as social software engineering is part of software engineering in general, social software engineering education should be part of software engineering education. So to summarize, as software is omnipresent in our society, think about this oxygen metaphor, which I have borrowed from Versen. It is continuously being influenced by society, and it is influencing society. And this means that it's our responsibility as researchers to understand how software is being developed, keeping in mind that it's developed by humans. I profoundly believe that by creating a more inclusive society of software developers, we are actually going to create a better society for everyone. And to this end, we need to understand experiences of developers from the minoritized groups and find ways to support them better. And we need to understand the way diversity and inclusion play in teams, and we need to find ways to support those teams better. And of course, despite all those challenges we have a wonderful, wonderful road ahead of us. I have spoken.